Hello, everyone! Today, we're going to tackle a super important topic from your Unit 6, electromagnetic induction, and that is the AC generator. Now, I know it can seem a little complicated, but trust me, we're going to break it down so simply that you'll remember it forever. And your exam marks for this topic? Absolutely safe. Cello, let's begin.
So, before we jump into the heavy physics, let's start with a very simple question to get our minds warmed up, okay? Just think about it for a second. We use electricity every single day for our lights, our fans, charging our phones. But have you ever really wondered how these big power stations actually make it? Well, the answer lies in a fascinating machine, and that's exactly what we're going to understand today. All right, so before we get into all the formulas and the diagrams, what is the generator's big secret? What's the main idea behind it all? It's actually a very simple but really powerful concept. Here's the big idea. A generator does not create energy from thin air. That's impossible, right? It would violate the law of conservation of energy. It's simply an energy converter. It takes mechanical energy, that's the energy of motion, of something spinning, and it just transforms it into the electrical energy that we all use. And this is the basic setup. It should look very familiar from your textbook. You can see the main parts: a coil that can rotate, powerful magnets creating a field, and these things called slip rings. The whole design is built for just one purpose: to make that coil spin and then use that spinning motion to generate electricity. You know, to make it even simpler, just imagine an old water wheel, like the ones you see in old movies, by a river. The flow of the river water pushes the wheel and makes it turn. That's mechanical energy. A generator works on the exact same idea. Something, it could be steam or wind or water, provides the force to turn a coil, and that turning is what produces the electricity. Right. Now that we've got the main idea locked in, let's get into the actual physics. Pay close attention here, because this is where all the exam questions come from. If you understand this part well, full marks are pukka.
Now this is the official principle you must write in your exam. An AC generator works on electromagnetic induction. So what does that really mean? It's simple, yaar. Whenever the magnetic field passing through a coil changes, a voltage, what we call an EMF, is created. And in our generator, how are we changing that magnetic field? We're doing it by physically rotating the coil inside it.
Let's break down that process step by step. First, we use some external force to spin the coil at a constant angular speed, which we call omega. As this coil is rotating, the amount of magnetic flux passing through it is changing every single moment. Now, what does Faraday's law tell us? It says that any change in flux must induce an EMF. And because the rotation is smooth and continuous, the EMF that's produced is also a smooth, alternating sinusoidal wave. And here it is, the formula that's going to win you marks. The instantaneous EMF, or epsilon, is equal to NBA omega sine of omega t. Let's quickly break that down. N is just the number of turns in the coil, B is the strength of the magnetic field, A is the area of the coil, and omega is how fast it's spinning. This one formula tells you the exact voltage at any given moment in time. Pretty powerful, isn't it?
Okay, let's put this formula to work with a quick and simple example. Imagine we have a generator with 500 turns, an area of 0.02 square meters, spinning at 50 radians per second in a magnetic field of 0.5 Tesla. We want to find the peak EMF, that is, the maximum possible voltage. Now, if you look at the formula, the sine function has a maximum value of 1, right? So the peak voltage happens when sine of omega t becomes 1. This makes our formula for peak EMF very simple. It's just N times B times A times omega. Cello, let's calculate.
So we just plug in the numbers. We have 500 times 0.5 times 0.02 times 50, and what do we get? We get 250 volts. See, that's a pretty significant voltage, and it's generated just by spinning a coil in a magnetic field. It's not magic at all, it's just pure, beautiful physics. All right, this next part is very important. Let's talk about some common mistakes. These are the silent killers that can make you lose marks in the exam, and I want to make sure none of you fall into these traps. So, the biggest misconception by far is this one. Students sometimes write that generators create energy. Please, this is fundamentally wrong and will definitely cost you marks. Always remember, generators are energy converters. They take mechanical energy as the input and give electrical energy as the output. That's it. And here's a very simple line you can remember forever to get this right. No spin, no power. It's that simple. If the mechanical input stops, if that coil stops spinning for any reason, the electricity generation also stops instantly. The output completely depends on the input.
Now, let's quickly see why this topic is so important. It's not just some machine you have to memorize. It actually connects many different ideas that you have learned or are going to learn in your physics syllabus. First of all, this topic is a perfect real-world application of motional EMF, which is the voltage you get when you move a conductor in a magnetic field. It is also the absolute foundation for your very next chapter on AC circuits. And what's really beautiful is how it connects two huge branches of physics: mechanics, with its ideas of rotation and omega, and electromagnetism, with its fields and flux. So for your final revision, just remember these 4 key points. Number 1, it's an energy converter. Number 2, the principle is electromagnetic induction. Number 3, the whole process is caused by the changing magnetic flux, which happens because of rotation. And finally, number 4, the peak voltage is given by NBA omega. If you remember these 4 things, you've got the whole story.
And I'll leave you with a final thought to ponder. This incredible machine, the AC generator, it changed the entire world using rotation, using moving parts. But what if, just imagine, what if we could find a way to generate huge amounts of electricity with no moving parts at all? That's a question physicists are working on right now. And maybe, just maybe, one of you will help find that answer one day. Thank you for listening.